Hi, good day viewers. Welcome to my YouTube channel. Today we shall be looking at geometric progression. In this video we are going to be deriving formula for the nth term of GP. Okay, what is geometric progression? Geometric progression is a form of a sequence which has common ratio between any of the terms and its preceding terms, and is sometimes called the exponential sequence. Let us consider an example here. Given 2, 4, 8. Now we observe clearly here that the value of r, which is the common ratio, are all the same here. So that means the ratio we have here must be equal to the ratio we have here. So how do we guess that? We simply say 4 divided by 2 is equals to 8 divided by what? 4, which is equals to what? 2. So if I have another value here, if I divide that value by this, it must have the same what result. So that's what they call GP. Another example is if we have 8, 16, 32, right? Of course, the common ratio is also equal to 16 divided by 8 equals to 32 divided by what? 16. Everything will give you what? 2. So you can have as many as possible. So when you have the same common ratio in between terms, it is said to be what? To be GP. Now the next thing we need to talk about is the nth term of GP. Nth term of GP. Now conventionally in GP, we denote the first term by A. First term by A, common ratio by half. Okay, now if you consider a particular sequence in GP, let me consider AR squared to AR raised to power what? N. This is the derivation of how we get the nth term of GP, right? So you observe that this particular A is said to be the first term, this is second term, this is third term, and this is number of terms here. So you observe clearly here that the value of R here is simply decreasing by 1. So that means if the first term is A, second term is AR, you know second term is supposed to be AR squared, but because we reduce it by 1, it simply becomes what? AR. Third term is also equals to what? AR raised to power 3, but because we reduce it by 1, it's simply what? AR raised to power what? 2. So the same thing here. Therefore, the nth term of GP is given by AR raised to power number of terms minus 1. So this is how they got the formula for the nth term of what? Of GP. So this is nth term of GP. Okay, let us verify this particular formula with one example on GP. Example 1 says find the seventh term of the sequence 4, 12, 36. Oh, interesting. Okay, so it's not difficult, just pay attention to how I'm going to solve this now. Solution. Okay, now find the seventh term. You know, we said this particular value reduces by 1. That means T7, which is seventh term, will be equals to AR raised to power 6. That what should come to your mind. So if you're given 8th term here, that will be AR raised to power what? 7. So if I replace this value here, how do I get my A and how do I get my half from here? I've established that protocol here on how to get R, and we know that the first value here, which is following this trend, simply what? The value of what? A. So we simply say A is equals to 4, and common ratio is simply equals to 12 divided by 4, and that will give us what? 3. So if I replace these two values into this particular what? Expression, I'm going to be having 4 times 3 raised to power 6, and 3 raised to power 6 will give 729. 729 times 4 will give that's 2916. This is 2916, and that is all. So guys, this is what I have for you today. Please can you like this video, share this video, and subscribe to my YouTube channel to get more updates on my next video. Stay tuned for the next class. Bye for now.